All right, so we'll pick this back up here. Last page, not too bad. This first question, though, I will say I kind of remember this one being a fairly rough this particular year because they made it sideways. This is the normal line. This is the interface. So unknown error. The angle of refraction is this angle. All right, that's the one we're measuring. So a little bit of a pain. A lot of kids messed that up that year. Looks to be 56 degrees. All right. Calculate the index of refraction. N1 sine theta 1 equals N2 sine theta 2. N1 is the unknown in this case. This is N1, N2. Remember, N1 is whatever one the light ray starts in. So it's N1 times the sine of 30. Don't forget the degree symbol. Times air, which is 1.0, times the sine of 56 degrees. All right, make sure you put it all in there. So N1 is going to be 1.0 times the sine of 56 divided by the sine of 30. Once you do the units once, you're good. All right, you don't need to show them all the way through. So we don't need to do this 1 times in our calculator, but I'll do it just to be thorough. Close parentheses, and 1 equals 1.66. No units on the X-ray refraction. 2-point question. An electron in a mercury atom goes from B to high energy level when it absorbs a single photon of 3.06 electron volts. So it's in B. So let's see what B's energy is. All right, so it's in B, negative 5.74. So I'm going to write that in my little diagram, negative 5.74. It's going to gain 3.06. So let's see what that would give us. Negative 5.74 plus 3.06 gets us up to negative 2.68. Okay, so negative 2.68, that corresponds to F. All right, F. This was B, this was F. So it's F. Oops, sorry, it's F. I did that in the wrong spot, my bad. All right, determine the energy of the photon in joules. Well, E equals HF, and it's 1-point question. Oh, but look, I don't know F. Oops, so that's not gonna work. But I know its energy. That photon's energy was 3.06 electron volts. All right, so I just have to convert that to joules. There's no actual equation from this, it's just a conversion. So 1 electron volt equals 1.6 times 10 to the minus 19th joules. So 1 eV per 1.6 times 10 to the minus 19th joules per 1 eV. So you have to do some dimensional analysis. So 3.06 times 1.6 e minus 19 gives us 4.9 times 10 to the negative 19th joules. This would be one of those ones where it'd be like the line and then the units would already be printed. You just have to put the number in. All right, calculate the frequency of the photon. Now I can say E equals HF. This is a 2-point question, so F equals E over H. It's 4.9 times 10 to the negative 19th joules divided by 6.63 times 10 to the negative 34th joules times seconds. So 4.9 E negative 19 divided by 6.63 E negative 34 gives us 7.4 times 10 to the 14th hertz. Then it wants to know what kind of electromagnetic radiation it is. So we go to the EM spectrum. We're looking for 7.4 times 10 to the 14th. So 10 to the 14th is that visible light range typically. So 7.4 would be in there. You can just say visible light. You could say violet light. You can't just say light. You could say violet light, visible light. You could say violet, visible light. I would leave off the color because just in case you did the math slightly wrong, I would just say visible light. Like that's the category, visible light. These are more specific, right? There's different versions of ultraviolet. Like every one of these has different subclassifications. So, you know, these are the general ranges. Visible light is the general range. You don't need to go any farther than that.